Good evening, everybody, and welcome to the second part in this two-part series on holding patterns for the EASA and UK instrument rating. So, before we get started, just a little bit about myself. So, I'm a single engine and a multi-engine pilot. I fly piston and turbine airplanes. I spend a lot of my time doing instructing for both the CPL and the IR courses. I'm an examiner as well, and I do all of that for both EASA and UK instrument ratings. And the reason these webinars have come about is that I often find that there's quite a gap between what people learn when they do the theory exams, the ATPL courses, and pass all their ATPL exams, compared to what they need to know when they turn up at a flight school to start an instrument rating or a commercial pilot license course. Or in the case of holds, that can also include a restricted instrument rating or the UK IMC rating, as it's also known. So the whole purpose of these webinars is to try to bridge that gap. So to try to teach you what you're actually going to need to do when you get in an airplane and go flying and how we do it. To help with that as well, we've also got a few online courses that we've developed. So we've got one that covers the instrument rating, so the full instrument rating as it's known, for both EASA and UK students. So everything you'd be expected to know going through that course. And then we've also got an online course that covers the UK only IRR or the IMC rating. And that covers everything you need for that theory exam and again for the online, again for the flight lessons as well. So that's enough about me. So what are we going to talk about today? So we're going to start with how to plan your hold pre-flight. So we looked at the breakdown of what's involved in a hold last week. So tonight we're going to have a little bit of a recap to start with, and then we'll jump into everything that you can do on the ground to prepare yourself to fly that hold once you're airborne. And next, we'll talk about the different hold entries, so the three different ways that you can enter a hold. And then lastly, we'll just touch on, there's only really 2 radio calls that you ever make in the hold that are about the hold at least, so we'll cover those as well. So jumping into it then, how to plan your hold pre-flight, or everything that you can do on the ground to prepare yourself to fly a hold once you're airborne. So last week we looked at this diagram, which is a standard hold. So we've got the four legs to the standard hold, which are all based around the holding fix. And if there was nil wind, if there was no wind when we went flying, each of these legs in the hold would be 1 minute long, and the entire hold would total 4 minutes. But as we all know, when we go flying, there is never nil wind. There's always some wind about. So there's 2 corrections that you'll need to make in the hold to account for the wind. The first is a heading correction, so that's to correct for any left or right drift that you've got. And the second is a time correction, and that's to correct for any headwind or tailwind. Now, when we talk about left and right drift and headwinds and tailwinds, I am talking about on the outbound leg. So that's what we're going to use as our reference for making these corrections. The reason for that is that throughout the hold, when we're on the inbound leg, we have to fly the inbound track. And when we're flying the 2 turns at either end, there's not much that you can do other than just fly a rate 1 turn. That leaves us with the outbound leg, which is the middle leg in this diagram here, where we need to make our correction to the heading for any left or right drift. So in this example that we saw last week, we've got a northerly wind. So on the outbound leg, you would need to turn left into the wind to correct for that. But because we've got the 1 minute turn onto the outbound leg, and we've got the 1 minute turn at the end back onto the inbound leg, we've also got 1 minute flying the outbound leg. That gives us a total of 3 minutes that it takes to fly these 3 legs. There's nothing we can do about the wind in the 2 turns, so that means that during the 1 minute that we fly outbound, we're going to apply triple the drift to correct for these 3 legs. We'll come on to recapping exactly how we make that calculation in a moment. Before we do that, we'll have a look at the second correction that you need to make for the wind in the hold, which is time corrections. So remembering that this was us changing that 1 minute that we fly the outbound leg, so flying it for more than 1 minute or less than 1 minute, depending on whether we've got a headwind or a tailwind on the outbound leg. So as we can see in blue here on the right, If you've got a headwind on the outbound leg, you'll need to fly outbound for more than 1 minute in order to get into a reasonable position back on the inbound leg. And on the bottom left there, we can see in orange that if we've got a tailwind outbound, it's the opposite. You'll end up flying outbound for less than 1 minute for the same reason. So that's the two corrections that we can calculate on the ground beforehand. But there are 2 points in the hold that we talked about last week as well that we can use to assess where we are in the hold, to assess whether we're in the correct position. And if we're not, we can make some kind of correction. So the first position that we used was the gate, and the second position that we used was the 60-degree to-go point. Firstly, the gate. Well, remember the gate was this 30-degree orange line here, so this line that's 30 degrees offset from both the inbound and the outbound tracks. The way we used it was we said if we turn if we turn outbound and we find ourselves reaching the gate too soon, like this aeroplane has here, so in other words, reaching the gate before we finished our outbound timing, we're going to turn to fly outbound along the gate. So if you reach the gate before your outbound time, you're going to need to make a turn to fly outbound along the gate. You'll fly outbound along the gate to the end of your timing. Once you've reached your outbound time, you'll start your inbound turn. And hopefully that's put you in a better position and you should be somewhere near the inbound track. So that was the gate. That's the first position that we can use to assess where we are in the hold while we're flying it. The second one was known as the 60-degree to-go point. So that's this point that this aeroplane's at in the hold here. And what we're saying is we've started the inbound turn. We're at a point where we've got 60 degrees of this inbound turn left to go. So in this example, the inbound track is 270 degrees. So 60 degrees before that, our heading is 210 degrees. So with 60 degrees of the inbound turn left to go, you should be 10 degrees off the inbound track. So ideally, you should be in that position that this aeroplane is in this diagram. That position is 10 degrees before the inbound track. So on the instrument there on the left, we can see the bearing pointer in blue there is showing 260 degrees, which is 10 degrees before the inbound track of west. So all of that gave us some points around the hold that we can calculate pre-flight. The first one was the abeam position. So we can work out what the abeam position is. Then we're going to have a track that we fly outbound. We can calculate a heading and a time that we're going to fly outbound for. At the end of the timing, we should be somewhere near the gate. So before we go flying, we can work out what the bearing pointer would be showing when we're on the gate. Then you're going to start your inbound turn. 2/3 of the way around this turn, you've got 60 degrees of your turn left to go. So we can calculate what heading the aircraft would be passing through at that point. And then lastly, we need to finish the hold by flying the inbound track back to the holding fix. So we've got a published inbound track and we can calculate a rough heading that we can use as a guide to fly to track that inbound track back to the holding fix. So we said a diagram like this can be very, very useful in your pre-flight planning because you can look at your hold, you can plan all the points around the hold, and you've got a good idea of exactly what you need to do when you get airborne. So we'll jump into some examples. Just before we do, here's a quick recap on how we make those two calculations to figure out what heading we're going to fly outbound and what time we're going to fly outbound. So this is a nice screen here. You can take a screenshot of it, or you can have a look at the replay later on, print this one out, because that takes you step by step through the calculations you'll need to make pre-flight. So that's all our recap of everything that we talked about in depth last week. So we'll jump into looking at a few examples of how we do this. So the first example we'll use, we've got this VOR hold here at Kavala in Greece. So the Kilo Papa Lima hold. And I've grabbed a random forecast wind here off of Windy. So on this day that I had a look, the forecast wind was 050 degrees at 25 knots at an altitude of 6,000 feet. Which incidentally, if we look at the Kilo Papa Lima hold on the left there, we can see Just to the right of the hold, it's got MHA 6000 written next to it there, which is the minimum holding altitude is 6,000 feet. So a 6,000 foot forecast wind will work well. Assuming we're going to progress from the hold into this approach, we'd expect to be starting it from roughly 6,000 feet. So this is going to be our first example. So going through those processes that we just looked at, firstly, to calculate what heading we're going to use outbound. So step one, we needed to calculate what our maximum drift is for our aeroplane. So the formula for that was 60 times the wind speed divided by your true airspeed. So that gives us 60 times the wind speed of 25 knots. And we'll assume that we're going to fly this hold at 120 knot true airspeed, which is fairly typical of most light twins. Things like DA-42, Senecas, Tecnams, etc. That's a fairly typical holding speed. So the maximum drift in the hold, using that formula, works out at 12.5 degrees. So if the wind was 90 degrees to our heading, we would drift 12.5 degrees. Next, we need to calculate what the angle between the outbound track is and the wind. So there's our wind there. We've got an arrow overlaid on the diagram. So the wind direction was 050 degrees. The outbound track on the plate there is shown as 089 degrees. So the angle between those two is roughly 40 degrees. And we don't need to be precise and calculate it down to the exact degree. These are just figures to help us figure out what we want to do once we get airborne. So rounding it to the nearest 5 or 10 degrees will give us a perfectly accurate answer. So we're going to say the angle between the outbound track and the wind today is going to be 40 degrees. Next, we can use the clock code to determine what the actual drift will be that we're going to experience while we fly this hold. So, using that angle between the outbound track and the wind of 40 degrees, the clock code tells us that because 40 degrees is, or correction, because 40 minutes is 2/3 of an hour, therefore the drift is going to be 2/3 of the maximum drift. We've just calculated that the maximum drift was 12.5 degrees, which means that the drift that we will actually experience flying that outbound leg is 2/3 of 12.5 degrees, and that's approximately 8 degrees. So we rounded it again to the nearest whole number of 8 degrees, because that will be more than accurate. So now we know flying outbound, we are going to get drifted 8 degrees, in this case towards the south. So the last step to calculate our outbound heading, we've just had a look at y. We need to take the drift and multiply it by 3. So on the outbound leg, we're going to use triple the drift, 3 times 8, that gives us 24 degrees. So the outbound heading needs to be 24 degrees into the wind. So in this case, that's a left turn. We've got an outbound track of 089, 24 degrees left of that gives us an outbound heading of 065 degrees. So now, when we get to the hold, we enter the hold, we turn outbound, we're targeting a heading of 065 degrees to fly on the outbound leg, which would look something like this. So we turn outbound, fly our outbound heading at 065 degrees. The question is, how long are we going to fly outbound for? So now we need to calculate our outbound time. To calculate the outbound time, first we need to know what the headwind or tailwind is on the outbound leg. So to do this, again we'll use the clock code, but first we need to know what the angle between the aircraft's wing is and the wind direction. So in other words, if we start at the wing, we need to figure out how many degrees forwards or backwards from the wind direction is, and that tells us whether we've got headwind or a tailwind, and we can calculate exactly how strong it's going to be. So in this case, we can see in the diagram there, the heading is 065 degrees, the wind is 050 degrees, which means the wind is 75 degrees in front of our wing. So we can take that figure of 75 degrees and use the clock code to determine the headwind or tailwind. Since 75 degrees is more than 1 hour, that tells us that the headwind on the outbound leg is going to be all of the wind speed. In this case, the wind speed was 25 knots, So we're going to have a 25 knot headwind outbound. And if you look at the diagram, that makes sense because we can see the outbound heading that we're flying and the wind direction that we've marked there with the arrow. We're flying almost directly into a headwind. So we'd expect it to be pretty much all of the wind strength. So we've got a 25 knot headwind outbound. We can see there on the left the outbound time. The formula we use is going to be 1 minute plus or minus 1 second for each knot of headwind or tailwind. Because we've got a headwind outbound, we're going to need to fly outbound for more than 1 minute. So now we're going to fly outbound for 1 minute and 25 seconds. So going back to this diagram that we looked at a moment ago, this is the information that we've got from the approach plate, which told us the outbound track was 089, the inbound track was 269, and from the wind forecast, which was 050 degrees, 25 knots. We can go around this hold. We can say the abeam position, which is 90 degrees across the hold. It's pretty much north, so it's going to be 359 degrees. That's where we're going to start. Our timer is either wings level or when we reach the abeam position, whichever comes later. Once we start the timer, we're going to fly that heading outbound of 065 degrees for 1 minute and 25 seconds. While we fly outbound, we're going to be monitoring the bearing pointer because it'll be hopefully starting to approach the gate at the same time that we're approaching the time of 1 minute 25. We can look at this diagram. We can say, right, the gate here, in this case, if the outbound track was 089 degrees, 30 degrees left of that, the gate must be 059 degrees. As we carry on around the turn, so we've reached the timing of 1 minute 25, we're going to start a right-hand turn inbound. 2/3 of the way around the turn, we're going to have 60 degrees to go, 60 degrees of our turn left to make. So with 60 degrees to go, 60 degrees before the inbound track. The inbound track is 269 degrees. So 60 degrees before that, we're looking for 209 degrees, which you could round and just say 210. So when your heading is passing through 210 degrees, you're going to be looking for that bearing pointer to be 10 degrees before the inbound track. And then lastly, we've got the inbound track of 269 degrees to fly, to track back to the holding fix. Because we had 8 degrees of drift, we'd expect that to track 269, we're going to need to turn 8 degrees to the right and fly a heading of 277 degrees to follow that track back to the holding fix. One person's asked a question there, so is it generally more useful to use your heading instead of track when timing the hold outbound? Yeah, so we're going to have to calculate a heading to fly outbound that corrects for the wind, and then it's usually quite a big correction because we're using that triple the drift formula. What was that there? So actually I don't mean track, I mean the published outbound track. So the issue would be you can't, unless you've got a GPS flying the entire hold and working everything out for you, which we're assuming that you don't for this, you can't simply fly the outbound track. So you couldn't turn outbound and just fly. In this case, you couldn't just fly an outbound track of 089 degrees because during the 2 turns at either end, the wind would be pushing you to the south. So if you flew the outbound track of 089, for that middle section, you would just parallel the outbound track. Then the turn at the other end, the wind would push you further south and you'd end up south of the hold. You wouldn't be back on the inbound track. So that's why we calculate this heading that's triple the drift outbound to hopefully put us back onto the inbound track. We've covered that in a little bit more detail in the last webinar where we looked into how we make these calculations and why exactly we make each one the way that we do. So I haven't got a diagram that will perfectly answer that question for you right now, but in the last webinar we covered that in a bit more detail. So hopefully that makes sense. Good. Okay, I'll just go back a second. So that's our whole planning complete for that first for the first example that we've got. So we've got a plan of how we're going to fly this entire hold before we get into the air. Now the wind might not be exactly as forecast. There might need to be some small changes that you make once you do get airborne, but we've got a plan that we can take into the air. And just like you do with PPL visual navigation, where you come up with headings and times that you're going to fly, you're going to fly along your navigation route, we do exactly the same thing with the hold. We've got a plan that we're going to take into the air. We'll fly the plan, we'll see how it works out, and if we end up a little bit south or a little bit too far north, we can make a slight correction once we're airborne to the headings and times that we're flying. But we've got a good plan that we can take into the air, and it will keep us within the holding protected area. And each hold that we fly, we should be able to make slightly more accurate. Good stuff. Okay, we'll move on to the next example then. So we've got another one here. So this is the Lima Alpha Romeo hold. So this is an NDB hold this time, Lima Alpha Romeo hold, which is at Lisbon in Portugal. So we can see there we've got an inbound track of 205 degrees and an outbound track of 025 degrees. Forecast wind I've got for this one, 4,000 feet, forecast wind, the direction 250 degrees, and a wind speed of 25 knots. So going through the same process then, to start with again, we're going to calculate the maximum drift. So the same formula, 60 times the wind speed divided by the true airspeed. So again, naturally we've got the same wind strength for this one, haven't we? So it's the same formula that we're calculating there. So again, we've come up with the same max drift of 12.5 degrees. Next, we're going to look at the angle between the wind and the outbound track. So in this case, we've got an outbound track of 025 degrees and a wind direction of 250 degrees. So the angle between those two is 45 degrees. So we can take that 45 degrees and we can use the clock code to determine what the actual drift will be on the outbound leg. So the clock code tells us that because 45 minutes is 3/4 of an hour, the drift therefore must be 3/4 of the maximum drift. Maximum drift we just said was 12.5 degrees. So 3/4 of the 12.5, again we can round it to the nearest whole degree and we come up with a drift of 10 degrees. Lastly, we need to calculate our heading outbound, which is always going to be triple the drift. So if the drift was 10 degrees, 3 times 10 gives us a heading correction outbound to make it 30 degrees. The outbound track was 025 degrees, turning 30 degrees into the wind, which again is to the left, gives us an outbound heading of 355 degrees. So we're going to reach the holding fix, start our outbound turn, and we're going to roll out on a heading of 355 degrees. It looks something like this. So once again, the next question being, how long are you going to fly outbound for? So to calculate your outbound time, first we're going to calculate what the headwind or the tailwind is. Once again, the angle between the wind and our wing, in this case, using the shortest angle there, we work out the wind is 15 degrees behind our wing. Using the clock code again to determine the headwind or the tailwind, 15 degrees is 1/4 of an hour. So the headwind is 1/4 of the wind speed. Wind speed we started with was 25 knots. So now we've calculated that we're going to have a 7-knot tailwind outbound. Next step then, our outbound time again is 1 minute plus or minus 1 second for each knot of headwind or tailwind. In this example, we have a 7-knot tailwind outbound. So we're going to fly outbound for less than 1 minute. So the outbound time now is going to be 53 seconds. Let me just have a quick read through some of these comments. What have we said? He means referencing the timing calculation to heading or outbound angle. It's generally more useful to use your heading instead of track when timing the hold outbound. The published outbound track. So the published outbound track in this case means 045. It means referencing the timing, which is the time we just calculated, to the heading or the outbound, or the calculated heading or to the calculated outbound. Yeah, I think so. I'm not 100% following exactly what the question is there. I think you're saying, are we better off calculating the timing by referencing the heading that we're flying, or by referencing the published outbound track that we're flying? So in this case, we've got a published outbound track actually I've written 045 there. That's not correct, is it? It's 025. That looks a bit better. We've got a published outbound track of 025 degrees, a published outbound heading of 355 degrees. Are we better off making the timing calculation based off of which one of those? At least I think that's the question. Let me know if it's not. I think ultimately the real world view of this is that what we're doing here is coming up with some rough figures that will put us in a better position in the hold. The calculations are never exactly perfect, so I don't think it would make a massive difference whether you use the outbound track or the outbound heading. The tailwind is artificially only 7 knots because of the heading correction. Yeah, so I would say that the more accurate way of doing it would be to use the heading that you've calculated, because that is the heading that you're going to get airborne, and that's the heading that you're going to fly. Therefore, that's the headwind or tailwind that you're going to experience, and therefore that's what's going to affect how far further. In this case, it's a tailwind, so how much further down the hole we're going to be pushed. So I would say it's slightly more accurate to use the heading that you're going to fly, and then base your timing calculation off of the heading you're flying rather than the outbound track. But that said, realistically, most days, most holds, the tracks, the headings that you're flying, the difference we're talking about is probably 5 or 10 seconds. Most of us can't fly accurately enough for 5 or 10 seconds to make a massive difference. The wind forecasts aren't accurate enough for 5 or 10 seconds to make a massive difference either. So realistically, it's a case of getting there, flying your plan for the first hold, and seeing what you need to adjust. Do I need to be a little bit more left or right? Is my timing, was it a bit too quick, a bit too long? Do I need to fly up and a little bit longer, a little bit shorter? So I would expect it's more accurate to use the outbound heading that you're going to fly. But equally, some people do teach to just use the outbound track that you're intending that is published for the hold. So both do work. It's not going to make a huge, massive difference to the accuracy of your hold in the end. But the way I've always done it is to use the outbound heading rather than the published track. Hopefully that answers your question. Okay. Moving on then. So we've calculated a 7 knot tail outbound. We've got an outbound time of 53 seconds. Perfect. So there was the hold we're flying. Once again, you're going to reach the holding fix, turn outbound. You need to know when to start your outbound timing. So you're going to start it when you roll wings level or when you reach the abeam position, whichever comes later. So the abeam position is going to be, for this case, when the bearing pointer is pointing to 295 degrees. From that point, you're going to fly an outbound heading of 355 degrees for a time that we've calculated of 53 seconds. While you're flying that outbound leg, we're looking for the bearing pointer to be moving towards indicating the gate. And hopefully at the time that it reaches, well, hopefully as we're reaching our outbound timing of 53 seconds, the bearing pointer is also approaching the gate of 355 degrees. That tells us we're in a pretty good position. We can start our inbound turn. We can calculate that 60 degrees before we finish the turn, so at 60 degrees to go, we're expecting to be turning through a heading of 145 degrees. So that's my reference point. Heading's approaching 145 degrees. Have a look at the bearing pointer. I'm expecting to see the bearing pointer 10 degrees before the inbound track. That gives me an idea of whether I'm going to finish my turn nicely on the inbound track or whether I can predict that I'm going to need to make a correction and which kind of correction I'm going to need to make. Get myself onto the inbound track. In this case, 205 degrees. We worked out the drift was 10 degrees, so I'm going to need to turn 10 degrees to the right onto a heading of 215 degrees, and that should have me tracking 205. So again, we've got a nice solid plan that we're going to take into the air. It will keep us within the holding protected area for the first hold that we fly. Based on what happens when we fly that first hold, we can make small adjustments and make every subsequent hold slightly more accurate from there. So, hopefully those two examples make everything we talked about last week a little bit clearer, because it can be a bit confusing when we're just talking about it in theory before we go through some clear examples. That's everything we need to know to fly the hold. But what do we do when we first reach the holding fix? And this is where we come into the different holding entries. So there are three different ways that you can enter a hold. We've got the parallel entry, the offset entry, and the direct entry. Which one of these entries you fly depends on your heading when you're crossing the holding fix. So when we first reach the holding fix, what is our heading? That tells us which entry we're going to fly, and it depends on which one of these three sectors we're approaching the holding fix within. So we've got normal standard hold there. We take the inbound track and we extend it outwards, and then we draw a line across the hold that's at an angle of 70 degrees, and that line is offset in the same direction as the gate. And that's what gives us our three sectors. So how do we fly each of these entries? Well, we'll start with the parallel entry. So the first thing you're going to do is you need to get yourself to the holding fix. So you're going to fly directly to the holding fix. That's what tells us that our heading is within the parallel entry sector. So when we hit the holding fix, for a parallel entry, we're going to turn to track parallel to the inbound track for 1 minute. That 1 minute, again, needs to be wind corrected. We correct it in the same way that we corrected the wind on the outbound leg that we've just calculated. So if you've already calculated an outbound time on the ground, you can use that same outbound time for your hold entry. So in the last example, we had 53 seconds, so if we were flying that hold, parallel entry, we'd fly parallel to the inbound track for 53 seconds. At the end of that timing, we're going to make a turn in the opposite direction to what the normal turns in the hold are. So we're going to keep ourselves on that protected side, so turning towards the holding side. And at the end of that turn, what we want to do, you've got two options here. I would argue the better option is to intercept the inbound track to fly it back to the holding fix. So make the turn, carry it on past the 180 degrees so that you can get yourself back onto the inbound track and fly that inbound track back to the holding fix. I say that's the better option because if you're on the inbound track approaching the holding fix, the subsequent hold that you fly afterwards when you reach the holding fix again is going to be more accurate because you're starting it from the inbound track. The alternative is you can make this turn and you can point straight for the inbound. You can finish the turn, point straight for the holding fix. So you can fly yourself straight back to whatever the hold is based on. You don't have to re-intercept the holding fix. The only slight downside to that is that you're now approaching the holding fix at an angle where you're offset from the inbound track, and that's going to make your next hold slightly less accurate. So that's the parallel entry. The next entry we've got to look at is the offset entry. So if we're arriving at the holding fix from within this smaller sector down here, we're again going to fly to the holding fix. From there, we will intercept and fly along the gate, which was that line 30 degrees offset from both the inbound and the outbound legs. Intercept that, we'll fly this track for 1 minute, again wind corrected in the same way that we've wind corrected our 1 minute every other point in the hold. At the end of that timing, we're going to make a turn in the same direction as the hold to put ourselves back onto the inbound track. intercept that inbound track, and fly along it back to the holding fix. That's our offset entry. And the last sector that we've got is the direct entry. So this is the big sector here. Lots of people seem to think the direct entry is the easiest one. A lot of the time I would argue it's actually probably the hardest one to fly, and we'll have a look at why. So the direct entry, quite simply, as always, we're going to start by flying to the holding fix. This is a good example here, where if we reach the holding fix and we start our turn outbound, we're going to need to fly slightly across the hold. So we're going to need to fly 90 degrees across the hold to push ourselves to the north a little bit and end up on approximately the outbound track. If you don't do that, you're going to overshoot the holding fix a bit, inevitably, and when you finish your 180-degree turn, you'd end up slightly inside of the hold, so you'd be further south of where this blue line is. So the solution to that is that we're going to start the turn, we'll roll wings level halfway through this turn, push ourselves 90 degrees across the hold a little bit, and then finish the turn onto the outbound track. The only question, or the only complication with this then, is how long do you fly that 90-degree sector across the hold for before we start our timer and fly the rest of the hold as per normal. So how long are we going to fly across the hold for? There's a few rules of thumb that we can use here. So we can figure out what our angle is between our heading and our inbound track. So in other words, how far offset from the inbound track we are. And then based on those few rules of thumb there, we can come up with a time that we're going to fly wings level across the hold for. So using the example we just looked at, this heading looks like it's about 220 degrees. We've got an inbound track of 270 degrees. So the difference between those two is going to be 50 degrees. That puts us into the last of those rules of thumb there, where we've got 45 degrees or more. It means we're going to fly across the hold for 15 seconds. So in this case, we'd turn outbound, roll wings level, 90 degrees across the hold, 15 seconds, then finish the turn outbound and fly the rest of the hold as usual. Another example down there, this orange line. We don't need to be super accurate with this. I would estimate somewhere around 20 to 30 degrees offset from the inbound track. That puts us into being between 15 and 30 degrees off the inbound track. So we can see there we're going to fly across the hold for 5 seconds and then finish the outbound turn. Lastly, this green line here, if we are approaching the hold at 90 degrees from the south like this, we're definitely 45 degrees or more off the inbound track. So we can hit the holding fix, start a timer for 15 seconds, fly, continue wings level across the hold for 15 seconds, then finish the turn outbound. Once again, these rules of thumb are just to roughly put you in the right position. They're not precise, they're not exact, and if you use one that was slightly wrong, it wouldn't make a difference. In reality, you could, every single time, if you're offset from the inbound track on a direct entry, you could fly 10 seconds across the hold, finish the outbound turn, and 10 seconds would be good enough. It would get you in a good enough position that we've got all those other points that we can use. You could see where you are relative to the gate, see where you are at the 60-degree to-go point, and you've got more than enough information there to get yourself back onto the inbound track. So that's why we say direct entry on paper often seems like the simplest, but in practice, it can be one of the hardest ones to fly an accurate entry with. So they're the three holding entries. So the only last bit that we've got to talk about are the radio calls that you might make in the hold. Now, there might be other radio calls that you make, or might be plenty of radio calls that you make in the hold about lots of other things, about the approach that you're about to fly and a clearance for that approach, or climbs and descents that you might be cleared for in the hold. When it comes to talking about the hold itself, what radio calls can you expect to make? The first one you might make when you're entering the hold. So when you reach the holding fix for the first time and you're starting your holding entry, you would say, for example, Delta, Alpha Bravo, Charlie Delta, entering the Kilo Papa Lima hold, altitude 3,000 feet. Regardless of which hold entry you're flying, that tells them that you're entering the hold. ATC are well aware of what the different hold entries are. So they're not expecting you to tell them which entry you're flying, they just want to know that you are entering the hold. Alternatively, you might be asked to report established in the hold. So once you are established in the hold, you would say Delta, Alpha Bravo Charlie Delta, established in the Kilo Papa Lima hold, altitude 3,000 feet. So what does established in the hold mean? Well, established in the hold, what you're saying to ATC is I have put myself within the hold. I am confident that I'm not going to leave the holding protected area. There might be a lower altitude that they can descend you to, but they need you to confirm that you're established in the hold before they can clear you to that lower altitude to make sure your terrain is safe. So established in the hold, usually we report that once we've finished our entry and we're starting our first complete lap around the hold. You wouldn't normally make both of these radio calls. It would be a one or the other. ATC usually don't need to know both when you're entering the hold and then once you're established 5-10 minutes later. They don't normally need to know both. They'll normally just want to know one or the other, and you might get asked to report either entering the hold or report established in the hold. So that's everything that I've got to say about holding patterns, really. That's over the last two videos, we've covered pretty much everything that you should need to know going into any type of instrument rating in the UK or in any EASA country to be able to fly the holds for your instrument rating tests. So lastly, before we go, as I was saying before, I've got a few online courses that we've created that talk you through everything that you need to know for your instrument rating or the UK IRR or IMC rating test. So let's just quickly, we'll have a very quick look just to give you a bit of an example. So everything that we talked about with the holds, we can see there the holding pattern section. So that talks steps through everything that we've talked about in the last two webinars. As another example, here we've got procedural versus vectored approaches. So there's a video there that talks through everything about the difference between procedural and vectored approaches. If you don't want to watch a video, all the information is included down below as well. So vectored approaches, procedural approaches. There's an example there. It talks you through step by step how you would fly this procedural approach. Different types of procedural approaches, alternate procedures, different outbound timings that you might see in different types of procedures that you would fly. For every step of the instrument rating course, we've walked you through what you need to know one by one. So flight planning, departures, airways and arrivals, holding patterns, approaches, and GNSS systems. At the end of each of these sections, we take a look at holding patterns, for example. We've got a whole collection of example questions that your examiner might ask you on test day, things that you're expected to know to help you with your instrument flying knowledge. So that's our online courses. We've got one for the instrument rating, there's another one for the commercial pilot's license, and a third one for the UK IRR IMC rating. So that's everything that I've got to say about holds. Plenty to talk about. Thanks you very much, everybody, for watching. If anybody does have any questions that they think about holds or anything else to do with any instrument flying, feel free to get in touch. As you go through your training again, feel free to fire me an email, ask me questions. More than happy to just have a chat, talk about instrument flying in general. I spend most of my life talking about it, so I might as well talk to some more people about it. Perfectly happy to give out some advice. So thank you all for watching, and we will have some more webinars planned in the future. So I'll publish those once we've organized them. So thanks everyone, and goodbye.